Okay guys, today we're going to work on adding, subtracting, multiplying, and dividing rational expressions. So some of this I think is going to be just kind of a little bit more of a furthering of what we've already done, and some of it we haven't really done this year, but hopefully you have done it at some point in Algebra 1 or maybe even geometry. So the first thing we're going to work on that I don't think we've done yet together as the class is the adding and subtracting of radical expressions. So the thing you have to remember here is you can only add or subtract what we call like radicals. And first of all, they have to both be a square root, or they both have to be a cube root, or they both have to be a fourth root. So you can't add different indexed roots together, but they also have to have exactly the same thing under the square root. So just as a little example, like if I do 3 square roots of 2 plus 5 square roots of 2. You can actually add those together. What you do is just take and add the numbers in front. This would be 8 square roots of 2. Now, I cannot do, like let's say I had 3 square roots of 3 plus 8 square roots of 5. These are not what we consider like radicals, so I could not simplify that any further. This would be the most simplified form of that expression. I can't combine anything because I don't have any like radicals. So you can only add them or subtract them if they have exactly the same thing under the root, and they both have to be the same type of root, like a square root or a cube root or a fourth root. So we're going to get into this here. These two guys have exactly the same thing under the root, x times y, so I just go ahead, this is 10 roots of xy. These can't add that any further. That's as simplified as that expression can get because they don't have the same thing under the radical. This has an x, this has a 5, so that's already been simplified. Now, what I want you to think about here in this next question, if you just have a plain, like this is minus the cube root of 9, think about that as having a little 1 in front of it. So I can actually subtract these. They have the exact same thing under the cube root. 8 minus 1 would be 7 cube roots of 9. Same kind of a concept here. I just have 1 cube root of 7 added to 6 cube roots of 7. These have exactly the same thing under the radical, so we can do that. This would be 7 cube roots of 7. I have 7 fourth roots of 5 minus 2 fourth roots of 5. These have exactly the same thing under the root. This would be 5 fourth roots of 5. And then final question here, that's as simplified as it can get because we do not have the same thing under the radical. Okay, now example 2. Sometimes it might not look like you have like radicals when you start the problem. None of the previous questions could be simplified in any way, shape, or form, but on this question, I'm just going to break down a couple of these radicals. Biggest perfect square that goes into 20 is 4. Biggest perfect square that goes into 45 is 9. And biggest perfect square that goes into 80 is 16. So if you already have something in front of the radical as you're breaking it down and you pull something else out in front, you go ahead and multiply those things together. So in this first situation, this first term is really 6 roots of 5. This second term is really 3 roots of 5. And then this third term, 4 times 4, we get 16 roots of 5. Now, initially when I looked at that problem, I didn't think I could do that, but as I broke down the radicals, they all actually turn out to be like radicals, so you can do this problem. So this is 6 minus 3, which would be 3, and then add 16 to that. The simplified answer here should be 19 roots of 5. Now these are cube roots, so be careful here. This is -4 cube root of 2. That can't be broken down any further. Biggest perfect cube that goes into 16 is 8. And the biggest perfect cube that goes into 54 is 27. So this will come out as a 2, this will come out as a 3, can be broken down a little bit. So I have -4 cube roots of 2. If you have something in front already, go ahead and multiply. So that's 14 cube roots of 2. And then this is going to be 27, 3 times 9, cube roots of 2. And so now, it didn't look like it, but we end up with like radicals here. So I'm going to do negative 4 plus 14 minus 27. So the final simplified answer here, negative 17, and then roots of 2. Notice in none of these situations am I changing anything under the radical. You don't actually add anything there. Those should stay exactly the same. And then just one more little example here. 50, 25 times 2. Oh, I made that too big, sorry. 32 is 16 times 2. Forgive me. I'm going to write it up here. 18 is 9 times 2. So that first term is really 5 roots of 2. Here I can pull out a 4, so that second term is really 12 roots of 2. And then, sorry guys, I had to write it up there. This third term is really minus 15 roots of 2. So we can actually combine those. I'm just going to do 5 plus 12 minus 15, which is going to simplify to 2 radical 2, and I can break that down and simplify it there. Okay, now what we're actually working on here is some multiplying and then adding or subtracting. So these are each binomials. If you guys remember, that just means they have 2 terms. So this is going to be a FOIL. So I'll just do a normal FOIL on this first problem. 2 times 1 is 2. 2 times negative 5 roots of 3. You're going to multiply the numbers on the outside, so that'd be minus 10 roots of 3. 4 roots of 3 times 1 is going to be just 4 roots of 3. And then this term on the end, 4 roots of 3 times negative 5 roots of 3, we're going to have negative 20. And then when I do square root of 3 times square root of 3, that's actually going to be square root of 9. So in the middle here, I do have like radicals. Negative 10 plus 4 is negative 6 radical 3. On the end here, what we really have is negative 20 times 3. So this is really minus 60. Only other thing I can do here is go ahead and combine 2 minus 60, negative 58, minus 6 roots of 3. And typically, if you do a problem like this, you're going to put any number that doesn't include a radical, like the negative 58 here. You're going to write that first. And the only reason we do that is just so people don't get confused and think that maybe we're subtracting 58 under the radical. So if you have a plain number with no radical, try and write that first. Okay, now, don't distribute this. Anytime you got a minus or a plus, you don't want to do that because you're going to miss out on a middle term here. What this really means is the square root of 2 minus the square root of 3 times the square root of 2 minus the square root of 3. Now, if you enjoy the FOIL, please go ahead and do that. I'm going to do a box on this one just for anybody that prefers that method, so whichever you like better. And I'll just set up a little box here, a little 2 by 2. Okay, right here, I'm going to get square root of 4. Negative square root of 3 times the square root of 2 is negative square root of 6. This will also be negative square root of 6. And then down here in the corner, the 2 negatives will become positive, and that'll be the square root of 9. Now, these guys are actually perfect squares. This is actually 2, and this is actually 3. And then make sure you think about this here. Both of these have like a little 1 in front of them. So when I combine my like terms here, 2 and 3 is 5. Negative root 6 is minus 2 square roots of 6. Okay, and then I'm just going to do C on this last one because these guys are going to be really similar, and we're going to talk more about this on the back. So just to save some time here. If you prefer the box, do the box. I'm just going to do a FOIL real quick. So square root of 5 times square root of 5 is square root of 25. Square root of 5 times the negative square root of 2 is the negative square root of 10. And this one, positive square root of 2 times positive square root of 5 is positive square root of 10. And then on the end here, positive root 2 times negative root 2 is minus the square root of 4. Now, these guys, we're going to talk about this on the back, but these actually cancel out here because you have one that's positive and one that's negative. This is equal to 5. this is minus 2, so this actually has no more radical left in the problem, and the final answer there is just 3, and we're going to move into that on the back. Okay, so what we just did there was an example of multiplying two conjugates together. And you guys, we touched on this at the end of the semester, right before winter break. So hopefully you guys are familiar with this. Conjugates are exactly the same with the exception of one has a plus in between the terms and the other has a minus. What happens with these radicals, when you have this, if you multiply it by its conjugate, you saw on that previous question, all the radicals canceled out. And so we're going to use that concept to rationalize a little bit more complicated denominators than what we were working with yesterday. So really all you need is to find the conjugate of the denominator of the fraction you're working with, and then you're just going to multiply top and bottom by the same thing. Remember, when we rationalize, we want to multiply by 1, so we don't change the value of the expression. So I'm going to scooch on down here to example 4, and I'm going to multiply the top and bottom of this by the conjugate of the denominator, which all that's going to be is to change out this minus to a plus. If I had a plus in the original problem, I would change that to a minus. Now notice exactly the same thing on the top and the bottom, and we're multiplying by 1. We're not changing the value of the expression. This will get rid of any radicals in the problem. So I'm going to go through this one real quick with you. I usually just try and, you guys see I left you guys a lot of space here. I usually just try to leave some space, and then I just go ahead and multiply the top and the bottom separately. So the top is really going to be just a distributive property because I only have one term up there at the top. So the numerator here, this is going to be 2 roots of 25 plus the square root of 5. So this actually simplifies to be just 5. And so the numerator here is going to be 10 plus the square root of 5. That's just the numerator. Okay, so I'll do the denominator in a different color here, and that's going to be to multiply this 2 radical 5 minus 1, 2 radical 5 plus 1. And I'll just do a FOIL. If you prefer a box, please do that. So 2 roots of 5 times 2 roots of 5 is 4 roots of 25. 2 roots of 5 times 1 would be 2 roots of 5. And then I'm going to do negative 1 times both of these terms. So minus 2 roots of 5, and then 1 times 1 is 1. This will be minus 1. So this is really 4 times 5, which is 20. These terms should cancel out, and then you have this minus 1 down here. So in total, this is your denominator. And so my actual answer to the question then, this is my numerator, 10 plus the square root of 5 over my denominator, which is 19. Now, if for some reason you could reduce that, you would want to. In this case, you can't. Now, I'm running really low on time on this video, so I'm going to pause it for a second, and it's going to look like I didn't do anything. But I'm going to write all the work for the next 2 questions and then go through them real quick. Okay, pause this at any time. I'm going to multiply the top and bottom by the conjugate of the denominator, and whatever you do to the bottom, you have to do to the top. Your goal is to eliminate the radical in the denominator of the fraction. So the conjugate here is 4 plus the square root of 15. You can see all my work for the numerator here. Pause at any time. The denominator, when you do the work for that, all the radicals should cancel out. And so basically what I was left with here was what I had in the numerator. The denominator ended up being just 1, and so when I stacked that back into the fraction, you could write it over 1, that's fine, or you can just go ahead and simplify that to 39 plus 10 radical 15. Please pause if you need to. The last example here is kind of a weird situation because the conjugate of the denominator is actually the numerator, and so sometimes this throws people off because they think all the radicals are going to cancel out, but that doesn't happen here. The bottom, you're going to use the conjugate, which should be 2 minus the square root of 3. When you do that to the top, though, the radicals do not cancel out when you multiply these together. So as I did the FOIL here, I ended up with 7 minus 4 roots of 3. The denominator, that stuff's going to cancel out, and here I actually ended up with 1. That doesn't always happen. It just depends on the question. I know it happened in the previous problem as well. But again, stacked those together and ended up with 7 minus 4 roots of 3.